Welcome to just a quick overview of the sheep-wolf predation. Now, today we talked about how different factors impact the growth of populations, whether it might be initial numbers, the growth rate, dependent factors such as energy and reproductive rates. So today you are finishing your wolf-sheep Jamboard looking at how variations in initial populations, energy levels, and reproduction rates influence not only the maximum level of sheep or wolf that you might get, but also how those populations change over time and how they impact one another. So just a reminder that you press setup to start your game. You can press go to make your game start and also to pause it. And you can make your speed of the game go fast or slow. You will change these numbers if you want to influence population. You will influence these three numbers if you want to influence energy, and you'll want to influence these two numbers if you want to influence reproduction rate. And then when you press go, you'll be able to see how those numbers change over time, which will allow you to get some data points. So I'm going to press pause here because it's pretty apparent that my sheep are going to inherit the earth. So when it comes to actually putting in this data, I'm going to be making a series of models that have a graph, but also my model number, what I did in terms of population, reproduction rate, and also energy levels, which you can also put in this information. And then you're going to want to put some key data points in here that will allow you to compare and contrast each of your models. So, for example, you might be talking about when your populations plateaued or reached their peak levels. So for wolves, it looks to be around 118 in terms of time, and then there were 400 wolves. And initially, my sheep had a max population of about 440 at around time 70. So I can put that data in, but I can also make broad observations such as wolf population crashing or exponential sheep growth. These are things that I can talk about when I look at the overall shape of the graph. Now, your control treatment, which you all probably have started, should just be the normal numbers that are given by the game. And a good idea is that when you go to do a new model, you only change one of these three parameters. So you might change population, energy, or reproduction rate. Now, once you have enough models where you think you can make some comparisons and some contrasts and some pattern evaluations, you're going to be making a series of generalized observations below your models. And you're going to be answering three main questions. The first is, what variations or how do variations influence a population's growth? How does changing reproduction rate or food availability or initial population change a population? What things maximized or minimized growth or changes over time? And then what evidence do you see for either population being R or K selected? R being a very fast reproduction rate and K being a bit more selective and slow. You will put these observations here, and it'd be a good idea to make sure to do very specific data analysis. So as seen in model 2 and 3 with the peak populations of 340 and 500, blah, 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 did this. So be really specific with your data analysis. Again, let me know if you have any questions or if you need any help with this work. I'm here to help, and then on Thursday we'll be sharing our results to think about what it means for countries around the world and the human population in general. Let me know if you have any questions. Have a good rest of your day. Take care.